Starting with the external ear, we've got the pinna, or the auricle, which is the external part of your ear that you could grab onto. And then the external acoustic meatus, or external auditory canal, is this part which goes through the external acoustic meatus of the temporal bone. The external ear is going to meet the middle ear at the tympanic membrane. So this little piece of plastic here is tympanic membrane. And as the sound waves hit the tympanic membrane, they're going to turn that energy into vibrational energy. So then we've got Malleus, this first bone here attached to the tympanic membrane, which vibrates on the incus, or the anvil-shaped bone, which then vibrates on the stapes, which is this stirrup-shaped bone. And the stapes is going to vibrate back and forth on the oval window. So right here where that stapes bone is attaching to the rest of this structure, we would call that the oval window. And then the vibrational energy is translated into pressure waves in the cochlear duct. So this snail shell shape here is the cochlear duct. Down here is the saccule. And up here, in between these semicircular ducts, is the utricle. As those pressure waves are bending the hair cells inside the cochlear duct, the pressure relief comes at the round window. So this little circle under here represents the round window, and that's going to come back into the middle ear. So take a pause for a second. Go back into the middle ear, right? Tympanic membrane. This is still normally air-filled. It might be mucus-filled as well, but the eustachian tube, or the pharyngeotympanic tube, also called the auditory tube, connects the pharynx to the middle ear, so you can equalize pressure on both sides of the tympanic membrane. If I take this part out, where the cochlear duct sits is the cochlea, or the bony labyrinth of the cochlea, which is within the temporal bone. These features here, these on X, Y, and Z axis, are the semicircular ducts, and they sit in semicircular canals. So the only part of a semicircular canal that we're seeing on this model is right here. And then finally, the rest of this structure just sits within the vestibule. So we would say this general region of the bone, or of the bony labyrinth, is the vestibule. So all these semicircular ducts are used for equilibrium, or your sense of balance, and that information gets transmitted to the brain through the vestibular nerve. The sound information from hearing goes through the cochlear nerve. So right here we've got the vestibulocochlear nerve running through the internal acoustic meatus. A couple other things that we see on the model. We've got the internal carotid artery here going through the carotid canal on its way towards the circle of Willis. And then over here we see a hint of the facial nerve, which is coming through the internal acoustic meatus, and then it's going to leave through the stylomastoid foramen.